It's August 26th, 2021, and welcome to the 30th Water Action Platform broadcast. My name is Piers Clark. I'm the chairman of the ISLE Group, and in today's broadcast, alongside the usual selection of water sector stories, we will showcase an astonishing new membrane technology, and we will hear from PUB in Singapore about their Global Innovation Challenge and how you can get involved. And our "and finally" story this week provides a mind-blowing change to our thinking on how pipes operate and whether a leaky pipe is actually a bad thing. The Water Action Platform is proudly open to all and free at the point of use. As of today, we have over 1,500 members from all around the world, 92 countries at last count, and from over 800 organisations. We have some brilliant sponsors, which include a broad church of organisations from investors to international finance institutions, utilities, OEMs, technology companies, trade associations, consultants and contractors. Thank you, sponsors. Now, we started these broadcasts back in March 2020, and our goal back then was to facilitate the sharing of knowledge, in particular around the COVID-19 pandemic. Over the past year, that remit has grown, and we now share stories about many other topics. And with this in mind, and noting that the peak urgency of the pandemic is, hopefully, behind us, I suggest that we shift the focus of these broadcasts away from the pandemic and towards what I believe is now the most pressing global issue. What is that issue? Well, you'd have to have been living under a rock for the past 6 weeks not to have heard about the recent IPCC report on the climate crisis. This report addresses the most up-to-date physical understanding of the climate system and brings together the latest advances in climate science. The findings were brutally stark. The world has run out of time to act. To avoid a climate crisis, action is required now. We cannot delay. COP26 will be held later this year here in the UK, but few people believe or are confident that their politicians fully own this important issue. There is a sense of hopelessness that many of us feel when faced with these stark warnings about the climate. What can we as individuals do? Well, I feel that we in the water sector, we have a particular responsibility. We are a sector which not only utilises significant amounts of energy in treating and pumping water, for example, but we also have great potential to create a positive impact, be that from generating energy from bioresources to building floating solar arrays on our reservoirs to a myriad of options in between. The water sector could lead the way in resolving this important global challenge. So my proposal, therefore, is that we shift the focus of these broadcasts to addressing how the water sector can address the climate challenge and how we, collectively, around the world, can achieve net zero. Now, I welcome your views on this suggestion. I don't want to shift the focus of these broadcasts without you, the audience, being supportive. So please feel free to comment in the live chat by clicking on the triangle to the right of your screen, or if you're watching this online, drop me an email. Now, moving on to our first story of the day, I am delighted to share news of the launch of the Make Water Famous initiative. This is a not-for-profit initiative and has been launched by Natasha Wiseman, founder of Wise on Water, a specialist water communications agency. Now, Make Water Famous will be a public-facing, multimedia, positive news platform, which is exclusively about water. Make Water Famous will be run by former national and regional press journalists with extensive experience working in the water sector communications and campaigns. And they're going to do 4 things. They're going to create positive news stories from around the world. 2, they're going to show how water touches everything from technology to infrastructure, environment, history, culture, well-being, sports. They're going to encourage the public to think about water in new ways and thus drive better understanding of the complexity of water management. And fourthly, and perhaps most importantly, it will provide support to individuals and organisations who want to help protect this precious resource. The value of a news service like Make Water Famous is that it drops the jargon, does away with the politics and gets straight to the heart of the issue, namely that water deserves to be celebrated and cherished. In fact, water deserves to be famous. Now, to find out more and how you can support this initiative, contact Natasha directly on this link here or drop me an email. We now come to our regular segment on vaccines and their variants from Dr. Jo Burgess, based down in South Africa. Her update in last month, which included insights into the Guillain-Barre syndrome, was just so incredible that a number of you asked for further updates. So here it is. Jo, over to you.
Hi everybody and welcome back. This month we're going to start with a bit of an update on the previous news items. Now, last month, if you were with us, you might remember we looked at the possibility that the Johnson & Johnson vaccine might trigger Guillain-Barre syndrome. There was an ACIP meeting the same day as our webinar, and I promised to tell you what went down. There was first a medical record review of the reported cases in the VA-ERS system using a protocol called the Brighton Collaboration Criteria. This is the established protocol for case reviews because the reporting system is open to the public and the data have to be quality checked before any decisions are taken. First, the working group needed to confirm the diagnosis of Guillain-Barre syndrome, i.e. there must be a formal diagnosis by a healthcare professional. You can't self-report these kind of syndromes. And further, then they had to characterise the clinical presentation, the severity, and the outcomes, whether recovery had taken place or what the outcome had been following the Janssen vaccines. So first they looked at whether or not it was in fact Guillain-Barre syndrome in every case or something similar. Then they looked at whether or not there was indeed a causal relationship. Guillain-Barre syndrome is a rapid onset syndrome, so symptoms develop within a few days of being triggered, or at most 4 to 5 weeks. And if you have a look at the red lines on this graph, you can see that of the 100 cases reported to the system, only 7 were within 21 days of vaccination with the J&J vaccine, and there was 1 more within 42 days, so 7.5 to 8 cases. Any new GBS diagnosis more than 35 days after vaccination is not what we call biologically plausible, and that means that the Guillain-Barre syndrome was triggered by something else. There are several diseases and infections that trigger Guillain-Barre syndrome, things like food poisoning and influenza, so it's not just vaccines that cause it. Now, if we look at this table of data, the ACIP meeting looked at the incidence rate among the J&J vaccinated population, and they compared that rate to the background rate, and they tried to assess it against the rate among COVID-19 survivors, because we know that COVID-19 can also trigger Guillain-Barre syndrome. The 7 cases after the J&J vaccination amount to 0.001% incidence of Guillain-Barre syndrome. And this is exactly the same as the background incidence, so that's people with no vaccine and no COVID-19 illness. Now, the blue lines on the graph on that last slide, you might have noticed, indicate 11 cases among people who'd received one of the mRNA vaccines, so that includes Pfizer and Moderna. That was 11 cases in 11,700,000 people, which is an even lower percentage than either the background incidence or the Johnson & Johnson. The conclusion, therefore, is that there is no significantly increased risk of contracting Guillain-Barre syndrome after receiving the Johnson & Johnson vaccine. For comparison, the rate after receiving a flu vaccine is 0.0012%, which is slightly higher than the background. But the rate after catching flu itself is 0.0172%, which is a much higher risk. It's safer to get the flu vaccine than the flu. And it's safer to get the COVID-19 vaccine than it is to get COVID-19, especially because we are seeing that evidence is mounting of people who've caught the disease in an earlier wave are at an increasing risk of catching it a second or even a third time when they're exposed to a new variant. Which brings us neatly on to variants of concern. And again, I want to revisit something I said last month when I spoke about the Lambda variant, which is another SARS-CoV-2 variant of concern which arose in Peru initially. Now, last month we looked at preliminary evidence showing the possibility of Lambda escaping immunity, which means it would evade therapeutic drugs to cure COVID-19, and it would evade prophylactic vaccines to prevent it. But thankfully and importantly, it seems that Lambda is fizzling out. Lambda, as I said, was first detected in Peru, and it spread quite rapidly across the Americas. In the USA, Lambda and Delta have been competing with each other for hosts, i.e. for people to infect. Delta is far more dominant, and you can see the rise and fall of Lambda on this graph. Delta is pushing Lambda away as an imminent threat in the United States. Delta is definitely driving the current wave in the USA, and it's affecting the unvaccinated population worst of all, which means, unfortunately, it's affecting children. So let's look a bit closer at this. The media have called the current wave in the US a pandemic of the unvaccinated. But at the same time, the media is full of frightening-looking headlines about close to half of hospitalized cases being vaccinated people, and this really gives us the information that the vaccine doesn't work. In July, at the end of July, it was reported that 40% of COVID patients in hospitals in the UK were vaccinated people, and 50% in the same month in Israel. So what's going on? Because that sounds really bad. This one is very counterintuitive, so hang on in there, and I will try to explain. The number is actually really good news. It reflects the really high vaccine coverage in Israel and in the UK. As vaccines go up, total hospitalizations will come down, but the share of hospitalizations among vaccinated people will increase. And this is not because the vaccines aren't working. It's because more vaccinated people exist in the population and there are fewer hospitalizations overall. So the July data for Israel show that 85% of the population was vaccinated, and about 4 people per 100, so 4% of the total population, were sick enough to be in hospital with COVID-19. With an 85% vaccination rate, that means 2 of those 4 cases are among the 85 out of 100 people who've been vaccinated, and 2 are among the 15 who haven't. And that means a hospitalization rate among the vaccinated of 2 per 85, which is about 2.3%, and an infection rate or a hospitalization rate among the unvaccinated of 2 per 15, which is closer to 13%. Now, those are pretty stable hospitalization rates. We see those across countries and across populations. So now let's look at a hypothetical population which is 50% vaccinated. For every 50 vaccinated people, we would see 2 cases in hospital, and for every 50 unvaccinated people, we would see 7. So that means the vaccinated hospitalized patients now account for 22% of hospitalizations rather than 50. And that sounds worse, but you can see that the picture is better than it was on the previous slide. Here, the dots represent there are 9 people out of a population of 100 in hospital. And with the previous slide, the 85% vaccinated population, we had 4 per 100 in hospital. So the percentage of hospitalizations or deaths of people who are fully vaccinated is a really bad way of tracking the effectiveness of a vaccination campaign. What we really care about is the hospitalization rate in vaccinated compared to unvaccinated. And our real-world data show that even for Delta, even now, the risk of hospitalization after vaccination is about 95% lower than the risk in the unvaccinated population. You will get these slides and a couple of links, and I hope if that didn't make sense, you can digest it in your own time. But in the meantime, back to Piers.
Thank you, Joe. We now come to our technology showcase, and this month it is the membrane company Agua Via who have developed an atomically precise membrane which could radically shift the cost paradigm for desalination. The company is in the final stages of securing a significant funding round which will enable them to complete their development. Here is Stephen Howard, Chief Executive, sharing more about their process.
Hi, my name's Steve Howard and I'm CEO of Agua Via Limited. Thanks to ISLE, we're pleased to introduce you to an early look at our technology. You'll see this technology roll out in our first projects in around 30 months with some of the leaders in the water sector. This is the splash page for the website of United States Department of Energy. From 2016 to 19, we were the face of the Department of Energy. The US President called us to help shape national water strategy. The Department of Energy website described our technology as the most atomically precise material ever built. Pictured here is the vertical stack of our technology assembled for water purification.
On top, a precision anti-fouling surface chemistry. Next, a one atomic layer matrix for precision filtration, and underneath a supporting substrate. The core of our technology is the one atomic layer thick, atomically precise matrix made of precision building blocks. This is a transformative technology. It will cut capital costs, cut energy use, contributing to the reduction of global greenhouse gases. Our technology mimics how aquaporins move water, but they're streamlined to give 1,000 times more flux than natural aquaporins. The filtration blocks are customized to deliver precisely the desired product water. This mimics the biologic paradigm of the human kidney, of keeping what is vital to live and throwing out everything else. There is no rejection ratio, and if you don't actually desire a solute, it does not go through. Using guided self-assembly, the individual filtration blocks tessellate to form a covalent bond matrix. It is one atomic layer thick. Rather than a statistical array of pores in conventional products, everything is precisely uniform. There's no dead space in the filtration surface, no tortuosity, with thickness and length that are essentially zero. If a filtration block is an ant from tip to tail, conventional membranes are a whale. Precision also delivers anti-fouling. The product's designed with a 9-tier anti-fouling strategy where the goal is to ultimately eliminate most or all pre-treatments and maintenance. Here we look at just one of those anti-fouling strategies, and that is to create custom surface chemistry tailored to a feedstock. The technology is packaged as a water treatment plant in a box. For purification, 6-inch cartridge cube delivers 100,000 gallons per day output. The unit is gravity driven by 1 psi for purification. There is no need for high pressure pumps for microfiltration. Backwashing is eliminated as well as post-treatments, all contributing to a small footprint water treatment in a box. Desalination is to follow.
As mentioned previously, Agua Via is in the final stages of securing funding, which will enable them to do the necessary scale-up and validation tests. Field operation is expected within the next 2 to 3 years, and so radical and game-changing is this technology that they already have a signed 30-year water purchase agreement with a major storage district in California. This is a technology to watch out for. Keep it on your radar, and we wish the team well. Now, talking of things to watch out for, our sector expert this week is Dr. Singh, Deputy Director in the Technology Department at PUB in Singapore. Dr. Singh is leading PUB's Global Innovation Challenge. Now, this initiative was initially launched in 2020 at the height of the pandemic, and it was launched as a way of keeping the global innovation community in water connected. Well, it's now in its second year, and earlier this month I spoke with Dr. Singh to hear how it was going.
Gurdev, it is wonderful to be with you today. Thank you for taking the time for sharing with us your thoughts around the Global Innovation Challenge. Could you start by telling us what the Global Innovation Challenge from PUB is, please?
Well, Piers, thanks so much for having me here. The Global Innovation Challenge, or GIC, is really PUB's way to source for game-changing ideas. We kind of had this idea around March 2020 when the pandemic was just starting, and we were really surprised by the boom in terms of open innovation that was happening all across. I don't know if you guys remember the story about how ventilators were running out and people were developing these open innovation concepts to develop ventilators across industries and some in their garages and backyards. We thought, hey, this is a great way for us to go out there and find open innovation and to find great ideas that we could use within PUB. We knew our current process needed some tweaking, so we decided to launch this Global Innovation Challenges to source for these game-changing ideas. Disruptive innovations that take place across different industry sectors, and then try to bring those technologies that are mature into the water sector so that we can get some of these game-changing solutions to our challenges. So that was really what the Global Innovation Challenge was about.
Excellent. So that begs the question, so how did it go last year? What were the successes from it?
Yeah, so we launched our challenge in September last year, and we had over 100 submissions, solutions in a very short period of time, about a month. But what was interesting was that 74% of these solutions were from entities that PUB had never worked with before. And there was a good diversity in terms of the solutions as well. We had a number of solutions where our engineers and scientists had never thought about. One of which was a challenge where our biologist was trying to look for a solution to basically monitor the chironomids. These are midges, insects that are at reservoirs, and they are a big nuisance in Singapore when the conditions are just right for them to proliferate. But the challenge was, how do we identify these species? There are 50 known species of them in Singapore, and only a handful of them cause a nuisance. So one of the solutions we got was this optical sensors combined with machine learning that was able to differentiate not just the number of these midges, but also the species of the midges, and right down to whether they were male or female, based on the wing speeds and the interference with the signals. Now, this is a technology that was maturing in the agricultural field, and it was just the right type of innovation we were hoping to attract into the water field to help with our challenge.
God, that is such a brilliant story. I love that. So I know that this year, and well done on developing a program that is pandemic resilient, that a way of keeping innovation alive during a global pandemic. That's incredible. Now, I know that this year you're repeating it, and you've got some themes. Is that right? Can you talk me through the themes that you're focusing around?
Yeah. So for our first challenge, our first cycle, we call it, we focused on automation and robotics as well as digitalization solutions.
The first challenge, you mean the one last year? The one last year?
Yeah, that's right. That's the one last year. In the current cycle two, as the National Water Agency, as you know, PUB manages the entire water loop, as shown in the central image of the slide. And then to improve the management of our infrastructure and operations, we are seeking solutions around 4 challenge areas. So the first is relating to the mapping of underground utilities. Here we are looking for non-invasive ways to provide accurate and complete information on the location of existing underground utilities before we commence construction and repair works. We note that there are several exciting developments taking place within the civil engineering field, geotechnical engineering field, and we want to hear about some of these innovations that we can bring in for us to basically map the underground accurately so that we can do away completely with the need for trial trenching. Now, the second challenge that we are most interested in is relating to the illegal discharge of prohibited organic chemical compounds. Here, we are keen for innovations that can pinpoint the specific prohibited organic compound being discharged, as well as when and where the discharge is taking place across the entire industry. For mapping the underground to mapping illegal discharge, in our third challenge, we want to map the rainfall across Singapore. Here, we want to increase the spatial coverage of rainfall intensity monitoring across Singapore beyond what we are doing with our rain gauges, X-band radar, CCTVs, and we really want to increase the ability for us to predict rain as well as flood. Now, the final challenge is something that we are experimenting with. It is to actually look for innovations to defend Singapore against sea level rise brought about by climate change. And here we are launching our inaugural challenge on coastal protection, where we are seeking innovative ideas and solutions that can help us to do that, defend Singapore against sea level rise while using less resources as well as land take, and also being flexible to adapt as sea level continues to rise. So these challenges are currently open, and it will close by the end of this month, August, and we look forward to solutions from all across the world to these challenges.
Yeah, and the beauty. Sorry, I was about to say the beauty of those 4 challenges is that they are universal. I don't think there's a water utility anywhere in the world that those challenges aren't going to resonate with. So it would be very exciting. Now, tell me, how do people get involved? We've got a global audience here. We've got 1,400 Water Action Platform members from 92 countries involving something like 850 organizations, utilities and supply chain. How can those members get involved in this? What's the process?
Thanks, Piers. I'm so honored to present in front of this group. So here's the website. It's as simple as, looking at the website. We've got videos on the challenges. We've got slides that tell you what the problem is about and what kind of outcome we hope the solution can bring. And apply. Basically, it's as simple as putting in your applications. If we like your ideas, if something that we want to further, we will provide all the opportunities we can for its development and subsequent adoption. Now, even if you're not an innovator, do look for opportunities to collaborate, to bring in some of these game-changing ideas from other industries into the water industry. And we really encourage collaborative project submissions as well. At the same time, we're also happy to partner organizations as outreach partners in terms of how we can proliferate and share more about the Global Innovation Challenge. And as well as, I think, something that you touched on, Piers, earlier, if we have common challenges that we both want to solve, there's also an opportunity for us to be ecosystem partners where we could put out challenges together and look for solutions for them.
Yeah. Brilliant. Well, last one to say is, Gurdev, can you promise me that you'll come back again in 2 or 3 months' time and tell us how things have gone? We need to know how this outreach has gone for you.
I would love to do that, Piers, and I really hope I can share some very exciting ideas and innovations out there.
Brilliant. Thank you very much for your time. It's been wonderful to talk with you, and all the best for the Global Innovation Challenge.
Thank you, Piers.
Here is the link to the Global Innovation Challenge website, where you can find out more about the challenges, the highlights from the programme, and learn how you can get involved. Finally, we come to this rather astonishing story about capillary action and water movement, which begs the question, is there actually a benefit to having a leaky pipe? Researchers at the Lawrence Livermore University have recently published a paper in the scientific journal Nature, which challenges how we think about water pipes and leakage. Their topic was on cellular fluidics, a technological platform in cubic building blocks with complex internal structures which are assembled to guide fluid flow using capillary action. Now, the system, which is based on how water flows in many natural systems, works because capillary action enables the flow of liquid in small spaces to happen without the requirement for external forces, such as pumps. Capillary action underpins many of the microfluidic technologies that we know around us, for example, dipstick sensors and most lab-on-a-stick devices. Now, the key element is the micro building blocks, and the Livermore researchers used 3D printed 1mm cubic cells with these 4 designs. Now, note how they get more complicated, and in particular note the purple one on the bottom right, the ISO truss design. By changing the shape and size of the struts in the cells, they were able to control capillary action. And when the cells were coupled together, their combined capillary action produced a controllable path through which the fluid flowed. The researchers found that for water, the isotruss design provided the most preferential flow. And by creating a pathway of isotruss cells next to each other, they were able to draw water along a route desired even uphill without needing a pump. The water, coloured red in this video, you can see is flowing upwards. The left-hand graph shows the velocity achieved along the x-axis. Now, the researchers went on to lay a pathway of isotruss cells which cause water, dyed green in this picture, to follow a specific spiral pathway, including vertically upwards in an open framework. Now, it's worth pausing to think about just how incredible that finding is. In an open framework, they were able to tweak, manage, control the capillary action using simple, cheap 3D printing. Now, this is clearly not going to provide a game-changing shift in our thinking about conventional pipes, but future applications could involve moving water through pipes which are not necessarily completely solid on the outside, or indeed completely hollow in the middle. There's lots more work required, but a flow path of isotruss cells inside a water pipe could mean less pumping and less leakage, even if the pipe wall has a defect. Now that would be pretty darn exciting. Now, I trust you agree that is a super cool development, and you heard it here first. With that, however, we come to the end of today's broadcast. Thanks again to our sponsors and our contributors, Joe, Stephen and Gurdev. The next webinar will be on Thursday the 23rd of September at the usual times. Megan will circulate invites shortly. Keep asking questions, keep sharing, and keep safe.